All right, if you've ever touched a database, you know there's a huge difference between a query that just works and a query that works well. Today, we're diving into the advanced SQL concepts that really separate the pros, the stuff that builds fast, smart, and solid databases. And yeah, this is exactly the kind of stuff that pops up in those tough technical interviews.
You ever been completely thrown off by a null value that just messes up all your logic? Or what about that query that takes forever, just crawling along for minutes when you know it should be done in milliseconds? And where do you even put all that messy, intermediate data? These aren't just little puzzles. They are the real-world challenges we all face. And the tools we're going to talk about today are the exact solutions.
Okay, so here's the game plan. We're going to tackle this in 3 parts. First up, we'll look at functions that pretty much make your queries think. Then, we're going to make them fast. I mean, really fast, by mastering indexing. And finally, we'll go beyond your standard tables to look at some special objects for solving those really tricky architectural problems.
So, let's kick things off with functions. And I'm not talking about your basic math here. We're talking about building some seriously sophisticated logic and data handling right inside your select statements.
You know, dealing with nulls is a classic headache. The NVL function is a simple fix, right? It just swaps a null for whatever value you want. But NVL2, that's where it gets cool. It's basically a compact little if-then statement just for nulls. If the value isn't null, it gives you back one thing. But if it is null, it gives you something else. It's pure conditional logic packed right into your query.
Next up, we've got scalar functions. The key thing to remember here is simple. One in, one out. You feed it a single value, and it spits back a single transformed value. That makes them your go-to tool for all kinds of things like, getting a string's length, rounding off numbers, or converting data types on the fly. Okay, pay close attention to this one because it trips up just about everyone at some point. The difference between count star and count column is absolutely critical. Count star, that counts every single row, no questions asked. But count column, it only counts the rows where that specific column actually has a value, so it ignores the nulls. Trust me, if your query result looks weird, this is probably why. Now, window functions are a total game changer. A normal aggregate function, like sum, squashes all your rows into a single result, right? Well, a window function lets you get a result for every single row while still being able to look at all the other rows around it. Think about calculating a running total as you go down a list, or maybe ranking employees within their department. You get all that amazing context without losing the details of the original rows. It's so powerful.
So why do we care so much about all these functions? Because they turn your queries from simple data fetchers into powerful little data processing engines. They let you clean up messy data and do some really complex analysis right there inside the database, which is going to save you a ton of time and code.
So we've made our queries smarter. But what good is a smart query that takes 10 minutes to run? It's useless. So how do we make it fast? Well, that's where our second topic, indexing, comes into play. First things first, let's clear up a super common point of confusion. What's the difference between a key and an index? Think of it like this. A key, like a primary key, is a rule. It's a logical concept that enforces something, like making sure every ID is unique. An index, on the other hand, is a physical performance tool. It doesn't enforce rules. It's a super fast lookup table the database uses to find your data in a flash.
So how does an index actually work its magic? Imagine trying to find a topic in a book without an index page. You'd have to read every single page, right? That's what your database does, a full table scan, and it's painfully slow. An index is literally like the index at the back of that book. It's a sorted reference that lets the database just jump directly to the right page or data block instead of reading everything. It's a massive shortcut.
But as they say, there's no such thing as a free lunch. While indexes make your read queries fly, they do add a little bit of weight to your write operations. See, every time you insert, update, or delete a row, the database has to update not just the table, but all the relevant indexes too. So the trade-off is pretty clear. You get way faster reads in exchange for slightly slower writes and a little more disk space. The main takeaway here is really simple, but it's so important. As your data starts to grow, indexing goes from being a nice-to-have to an absolute necessity. It is the #1 tool you have for making sure your application stays fast and responsive at scale. All right, for our last section, we're going to look beyond the standard table. We're talking about special database objects that are designed to solve unique problems that a regular table just can't handle on its own.
So what happens when you've got this complex process and you need a place to just store some intermediate results for a bit? That's where temporary tables come in. A local temp table, which you mark with a single hash, is like your own private scratch pad. Nobody else can see it, and it vanishes when you log off. A global temp table, with the double hash, is more like a public whiteboard. Everyone can see and use it, and it only disappears once the very last person using it has disconnected.
Now let's talk about views. A standard view is really just a saved query. Every single time you go to use it, it runs that query all over again to give you fresh, live data. A materialized view is totally different. It actually runs the query and then stores the results in a real, physical table. This makes reading from it incredibly fast, but the data is only as up-to-date as the last time you hit the refresh button.
I absolutely love this analogy because it just makes the whole concept click. The standard view is that live webcam. You're always seeing exactly what's happening right now, but it might take a second to load the stream. The materialized view is like a photograph of that same car park taken every hour. It's instant to look at, but it's a snapshot from the past. You just have to decide which one you need. Is speed more important, or is having real-time data the priority?
And finally, we have the sequence. The best way to think of this is as a dedicated number dispenser that just lives in your database. Its only job is to hand out the next unique number in line, which is perfect for generating primary keys. And because it's its own separate object, it's way more flexible than just an auto-incrementing column on a table. You could, for instance, have multiple tables all pulling unique IDs from the same central sequence.
So at the end of the day, what are these things? They're specialized tools for very specific jobs. They give you the architectural patterns you need for things like handling temporary data, caching results to get a huge speed boost, and generating unique IDs in a really flexible and robust way.
And that pretty much wraps it up. We've gone through intelligent functions, game-changing indexes, and all these specialized database objects. These aren't just parlor tricks. These are the tools that take you from just writing queries to actually engineering powerful, efficient data solutions. So the only question left is, how are you going to use them to turn all that raw data into fast, reliable insight?